4, 3, 2, 1. And liftoff of OSIRIS-REx, its 7-year mission to boldly go to the asteroid Bennu and back.
Hydraulics look good. Articulate pump speeds and chamber pressures are within family. Main chamber pressures have plateaued, begun to ramp off.
Heard the voice of Marty Malinowski. The Atlas has begun a pitch and yaw maneuver to steer to its planned path. 38.5 degrees inclination from the equator.
Welcome to our happy post-launch news conference. Here to discuss how our countdown on our launch and the status of our mission. We'll begin first with Ellen Stofan, the NASA chief scientist from NASA headquarters. Jim Green, the planetary division director from NASA headquarters. Dante Loretta, the OSIRIS-REx principal investigator at the University of Arizona. Scott Messer, the program manager from United Launch Alliance for NASA missions. And Rich Coons, the OSIRIS program manager for Lockheed Martin. And we'll begin first with Ellen Stofan. Ellen?
You know, tonight is a night for celebration. We are on our way to an asteroid. You know, right after the launch, my son was here, and his fiance turned to me, and she said, "Why am I crying?" And I was crying. And I said, because we've just done something amazing. As a country, the contributions you've seen from this team, who you're going to hear from some of tonight, we've built an amazing spacecraft, OSIRIS-REx. We've launched it. It's now on its way to Bennu. We're going to get amazing science out of it. We're going to be answering some of the most fundamental questions that NASA really focuses on. How does this planet work? How did this planet form? And we're even going to be looking at questions as basic as where did life and how did life originate on this planet? This mission is huge contributions to science. We're really excited. We're on our way. And as my boss, Charlie Bolden, said earlier, every day at NASA, we're turning science fiction into science fact, and that's what we did tonight.
Okay, thank you, Ellen. And now to Jim Green, our planetary division director from NASA headquarters. Jim?
Thank you very much, George. Indeed, NASA did it again. I mean, from a planetary science perspective, we're making enormous strides in understanding our solar system and our place in it. You know, everything we knew about the solar system just 50 years ago, we got primarily from the back end of a telescope or from meteorites that fell. And when the meteorites fell and we wanted to know where they came from and what their composition was and how did they get to be where they were, this mission will make enormous strides answering so many questions that have come up in those 50 years. It's just truly amazing. And it requires an enormous number of people to do that. Many of the centers work together. You know, at NASA headquarters, I have my team here, our program scientists, Christina Ricci, deputy program scientist, Jeff Grossman, our program scientist, and Gordon Johnston, our program executive. These are my eyes and ears as to what's happening, and they stay in touch and help me work all the issues at NASA headquarters, remove the obstacles that allows the missions to proceed. And of course, there's all the technical teams that do their work. You know, Goddard Space Flight Center. Here we are at Kennedy Space Flight Center. So indeed, it's a wide NASA effort. that goes right into the science community with the University of Arizona, our lead investigators, and our principal investigator here. I can't tell you how exciting this is. You're just going to have to take my word for it and watch it unfold. What will happen when the samples come back will be decades of study. And that's what's really exciting about it. The ability to hang on to those pristine materials, pose questions, and go to them and have them answer them for us through the analysis tools we have. It's really quite a milestone. You know, planetary science is, for me, where it's at. And we just keep hitting it out of the ballpark. And tonight, we hit it off the face of the earth.
All right, thanks, Jim. Now, Dante Loretta, the OSIRIS-REx principal investigator from the University of Arizona. Dante?
Thank you, George. Well, you'll all be real glad to know we got everything just exactly perfect. It was an amazing evening for me and for this team. This represents the hopes and dreams, hard work, blood, sweat, and tears of thousands and thousands of people have worked on this program for over a decade to make this a reality. I do want to mention that the mission is dedicated to my friend, my mentor, Dr. Michael Drake. Mike passed away just 4 months after we were selected by NASA to lead this mission, and you know, he left some parting words when I had to say goodbye to him. And he said, you know, first of all, you can do this. You've got the team. We're one team. These are big questions. Everybody's rooting for you. Everybody's behind you, and we can take that and lead them forward. I want to recognize a couple people in the audience. My deputy principal investigator, Ed Bayshore, came on right after I stepped into the role as the PI and has really led the science team throughout development. Ed is retiring. After this is a great way to go out. Heather Enos is coming in as the deputy principal investigator to lead us into operations, and she brings a lot of experience from Phoenix Mars Lander, Mars Odyssey, and other major NASA missions. It's a really proud moment for the agency. I'm honored and privileged to be able to lead this mission for NASA, and I'm glad the University of Arizona continues to be a strong partner for NASA as we go forward on this journey to Bennu and back. So we've worked hard to get to this point. The best times are ahead of us. We are going to get to asteroid Bennu. We're going to map it. We're going to pick that site. We're going to get that sample, and we're going to bring it back to Earth in 2023. And so I can't tell you how thrilled I was this evening. It was a wild, emotional ride, thinking of everybody that's with us, that's not with us, and all of the anomalies that we troubleshot, none of those came up. We hit all of our milestones within seconds of the predicts. Really kicked that field goal right down the center of the goalpost. So NASA has done it again, absolutely. Back to you, George.
Thank you, Dante. And now to Scott Messer from United Launch Alliance, the program manager for NASA's mission. Scott?
Thank you, George. I just wanted to start out by saying, how about that launch? I mean, was that not awesome? I mean, the Delta or the Atlas V rocket performed impeccably this evening. We looked at the countdown was just crystal clean. Hardly anything going on. As Dante said, we hit all of our milestones just right on time, and in most cases a little bit ahead of time. I just listened to the quick look review on the way back, and the vehicle performance was absolutely perfect almost. The engineers were trying to fight with one another over who could be the most nominal on their system performance. So the vehicle was very good. The orbit that we hit was almost perfect. The spacecraft has already made some little minor corrections, and they were thrilled at just how perfect the orbit was. So that was great. So I want to just say congratulations to NASA and the entire OSIRIS-REx team, as well as all of the families that have spent countless hours with their husbands, wives, fathers, and mothers out supporting this launch. It's been wonderful. So just a little bit more, the OSIRIS-REx mission is the third mission in the New Frontiers program. The first two missions were New Horizons and Juno, and both of those launched on an Atlas V as well. And it's been thrilling for us to be part of the mission's success and the discoveries and the images that the New Frontiers program has seen. You know, our experience at ULA is that sustained reliability and mission success only come if we have great partners to team with and to be very well integrated with. And this team, the Goddard team, the Lockheed Martin team, the entire team has just been a great team for us to work with. We're thrilled to be part of these critical missions, and we'll continue to maintain our focus on mission success for all of our customers. And once again, I just wanted to say thanks to all of our all of our partners who've worked on this great mission, and we are excited to be part and to get OSIRIS-REx on its way. Back to you, George.
Thank you, Scott. Now to Rich Coons from Lockheed Martin. He's been with us here at Kennedy for a number of months, helping to get OSIRIS-REx ready for launch tonight. Rich Coons is the OSIRIS-REx program manager for Lockheed Martin. Rich?
Thank you, George. So let me start by saying that the OSIRIS-REx spacecraft is happy and healthy. And I can't tell you how proud I am of everybody that was involved in getting us to the point that I could say that. We started the journey with a phenomenal launch on the Atlas V. It delivered us right where we needed to be, and we separated on plan within a minute of when we said we would. And since then, it's just been knocking milestone after milestone. So once you stopped being able to see the rocket, there was still actually about an hour's worth of work that went in on the ULA team side to make sure that we were delivered to where we needed to be. So at about 8:05, we separated from the upper stage. We immediately were able to start receiving some telemetry back from the vehicle. Since then, we've done a number of different things. We've initialized the propulsion system. We have gotten the solar arrays out and deployed. We're able to balance the power on both arrays. They're both moving. We've been able to articulate them in both directions. We have slewed the vehicle on its thrusters, so the prop system is working as expected. We were able to slew to the communications attitude. And within 40 minutes of being separated, we had established two-way communications with the ground station in Canberra. So that whole experience was incredibly nerve-wracking. But it is working absolutely as we designed it, absolutely as we tested it on the ground. So now all that I can say is let's go get the science, and let's get into that outbound cruise phase. And couldn't be happier with the work of everybody. Thank you, George.
Thank you, Rich. Hey. All right, we're ready to take questions now. Please give your name and affiliation when the microphone comes to you. And we'll just start right here in the front.
Jim Siegel. I'm with Celebration News and Space Flight Insider. I have a question about I'm excited for you for all of the science that you anticipate receiving. And I understand that the mother lode is going to be the material that is returned in 7 years. But I expect that prior to that, you are going to be making a number of other discoveries that are going to be important. And I wonder if you could describe when and what some of those things might be prior to 7 years from now.
Yeah, so OSIRIS-REx has really benefited from three major science campaigns, and I think the science team is really fortunate. The first one was getting ready for the operations using astronomy techniques. We had ground-based telescopes, space-based telescopes, and we did a very thorough job characterizing Bennu to the greatest extent possible with all of those assets. The second phase is going to come during the asteroid encounter. We have an amazing set of scientific instruments. We got the OCAM suite from the University of Arizona, the OSIRIS-REx thermal emission spectrometer from Arizona State University, our visible and infrared spectrometer for Goddard Space Flight Center, and the laser altimeter from the Canadian Space Agency as an international contribution. And we also have a student collaboration called the Regolith X-ray Imaging Spectrometer. It's going to be the greatest remote sensing mission of an asteroid ever performed. We are going to map this thing globally. We have to do that for our sample return science, and that's what's driven the flight system design and the mission design. But we've got a lot of other plans for what we're going to do with that data. We're going to understand asteroid geology, dynamical evolution, orbit, trajectory, the Yarkovsky effect. We're going to ground truth that telescopic data, and we're going to study regolith, or the blanket of gravel and dust on the surface of the asteroid, in a microgravity environment, which is really a whole new realm of astrophysical investigation. So the mission will have phenomenal science from the asteroid encounter leading up to the sample acquisition event, and then of course the final stage to cap off the trilogy of science that OSIRIS-REx will bring is the sample return investigation starting 7 years from now.
You know, I can imagine as we get closer and closer, the images are going to be absolutely riveting. Now, one of the things that we also did, as Dante mentioned, is using our ground-based assets, such as radars. We've hit this object before with radars, and we've gotten return echoes. This is how we know some of its basic characteristics. But when we get there and get up close and personal, really review it, we can then go back and look at the radar data and get a better interpretation of what that means. This will be the first major asteroid we've seen and visited in a way that helps us understand the observations from ground-based measurements that we've made. We call that ground truthing, you know, be able to be there and see that. That's going to help us in so many other ways as we take more observations of other objects, as we do continue to do radar. We hit maybe 70, 80 asteroids a year using radar techniques. So, you know, it's going to help the program all over the place.
Mm-hmm.
Thank you. Further questions? All right. We'll take one right here.
Sawyer Rosenstein with Talking Space. I know that obviously this mission is dedicated to the original PI, and you had the plaque for Mike Drake and everything. And I was wondering your thoughts now that this is in space and on its way, about him basically getting on his way to the asteroid.
Today's been a bittersweet moment for me, and I'll admit, as I was driving through the Air Force Station on my way to the ASOC, you know, I was alone. I had some time to think, and I really missed him. I mean, he would have been thrilled right now, and this would have been a great achievement for him. And I wish he was there with me. So that was the deal when he brought me on as a deputy. I was supposed to just handle the science side of the business, and he was going to handle all the administrative stuff, the management, and. You know, he had parting words for me about being able to take this team forward and carrying, you know, the torch for the next generation. And he really believed in that. He really believed the reason that we fly these missions as a nation, why we invest in these kinds of endeavors, is for the great science, but really for the educational opportunities, the inspirational opportunities. We want people to realize the impossible, to see what you can do creatively, constructively, when people come together, dedicated to a program like this, dedicated to mission success. And I mentioned the thousands of people who have worked on this, and it's the human spirit. You know, OSIRIS-REx is us. You know, we're taking those sensors out deep into the solar system. Those are our eyes. Those are our information that we're bringing back so we can better understand the big questions. Where did we come from? You know, and where are we going? What is our future? And really, are we alone in the universe?
All right.
Sarah Hammond, Arizona Public Media. Dante, can you talk a little bit about the University of Arizona's legacy of planetary science that has brought us to the OSIRIS-REx mission?
I'm a professor in the Lunar and Planetary Laboratory at the University of Arizona, and LPL has over 50-year history of supporting NASA spaceflight programs in planetary science. Our founding goes back to the very beginning of the space age with Dr. Kuiper, who provided the original lunar atlases for selecting the Apollo landing sites and the Surveyor landing sites in support of the very first NASA planetary exploration missions. And it really is standing on the shoulders of giants. It's awe-inspiring for me to go back and look at the history of LPL, because we've been involved in Voyager and Pioneer, Mars Phoenix Lander, Mars Reconnaissance Orbiter, Mars Global Surveyor, and Cassini, Messenger, Deep Impact. All of these missions have had a major LPL presence on them, and so we wouldn't be able to do the OSIRIS-REx mission at University of Arizona if it wasn't for that long history. A lot of the people on the team cut their teeth on those programs, and I was able to harness all of that talent and focus them on OSIRIS-REx to make it the success that it has been to date.
Right, we've got a question, a calling question. We'll take that, and then we'll come back and take some more here. Question on the phone. All right, we were not able to get our questioner, so we'll come back here. Question right back here.
I'm Almenas. I'm from Nicholson Student Media at UCF. I was just wondering, obviously this has a big presence nationwide, but how will the success of this launch affect Orlando as a community?
I think anytime the NASA family accomplishes anything, it's a big boost. And certainly our presence here in the Orlando area at Kennedy Space Center, the launch operations that we do here at Kennedy is so critical to NASA's success. It's critical to every spacecraft. I think sometimes, I'm on the science side, and a lot of the times when people think about what we do, they think about the great scientific discoveries, our rovers on Mars. And what it's really important to remember is we'd never have those rovers on Mars. We wouldn't have OSIRIS-REx on its way to an asteroid if it weren't for the people who worked so hard here at Kennedy Space Center who made this launch successful, our partners at United Launch Alliance, our partners at Lockheed Martin. There's people all around the country who've had a hand in making this mission a success. And they're all critical to really pushing the boundaries of exploration that we do every day at NASA.
And I'll just add to that, we do have science team members based at the University of Central Florida. Umberto Campings is a co-investigator on the program, bringing expertise in asteroid astronomy, asteroid spectroscopy, and characterizing Bennu using those ground-based telescopes that I mentioned as well. So we're really proud of UCF's contribution to OSIRIS-REx, and we look forward to continued collaboration.
Additional questions here in the room. Let's come right over here on this side.
Amanda Barnett with CNN Digital. Congratulations to the team. Sounds like everything went well tonight. It was a drama-free launch, but what's the next moment where you might be holding your breath a little bit? And then if someone could talk about this gravity assist, which is coming up in about a year, and what you expect to get from that.
I can do it. So we launched today on a trajectory that's going to bring us back to the Earth about 1 year from now in September of 2017. And we will be using an Earth gravity assist primarily to change the inclination of the orbital plane, because Bennu, our target asteroid, orbits about 6 degrees off from the orbit plane of the Earth. So we'll use basically flying underneath Antarctica to bend the spacecraft trajectory up onto that rendezvous trajectory with the asteroid. For me, the next real moment of truth is when we get the first resolved images of the target asteroid, because everyone on the team has some image in their mind of what Bennu is going to look like. And it's going to be phenomenal to see what it really looks like. We had a great reminder of this with the European Rosetta mission when they got to their target comet, and they saw that phenomenal geology that was going on that comet nucleus. It really just blew us away. And I showed that to the team, and I showed them this is what they thought the comet was going to look like before they got the camera images back, and this is what it looks like in reality. And for us, it's really going to set the pace of the entire encounter, because we're going to understand right away what kind of challenge are we up against, right? Is this going to be literally a walk on the beach, or are we going to have a lot of work to do to get to that sampling site so we can get that precious sample back to Earth?
Okay, right here to this lady right in back of the lady who just spoke.
I'm Jackie Goddard, working for the Times of London. If we waited 160 years, there's a chance the asteroid could come and visit us instead. Could one of you talk a little bit about the value of this mission to future deflection technology? Thank you.
Well, we've been looking for near-Earth objects, their size, where they go in terms of how potentially hazardous they might be. And indeed, this asteroid orbits between Venus and Mars and crosses our orbit. So it can be a potentially hazardous asteroid. Kepler's helped us tell us how these things move, but objects like this are really pushed with photon pressure. They absorb photons, and as they spin, they radiate them again, and that changes their trajectory. So that's called the Yarkovsky Effect, and that violates what Kepler would tell us it would do because there's additional physics there. That's really critical for us to understand a whole class of asteroids that behave in this manner. And so understanding the surface properties, their characteristics, what they're made of, will tell us how that absorbs the light, holds it, and then re-emits it, pushing the asteroid in these kind of directions. So this aids us in a whole series of ways. One, it helps us do a better job in determining the exact orbit over several centuries. Okay. Two, it enables us to use what we've learned on a whole class of asteroids to predict their orbits to determine if they're even more hazardous than we thought they were. So it's a huge step for us all the way around.
Okay, let's go back to Ken Kramer here in the back.
Hi, thanks for taking my question. Ken Kramer, Universe Today and the Northeast Astronomy Forum. Congratulations, I'm just back from the pad, seeing that great launch, so I'm a little out of breath and missed the earlier question period. Sorry if this is a repeat, but my interest, as you know, is in the chirality and the amino acids. So what I want to know is talk about when you get that sample back. How quick is it going to come back? How quick is it going to get to the scientists? And how quick do you think you'll be able to determine if there's amino acids there, if they're chiral or not? Thanks.
So OSIRIS-REx has always had the strategy, and everything we've done is go slow and careful and methodical, and that is absolutely going to be the plan when we get that return sample back. So we are actually still writing the sample analysis plan, and I don't want the team to finish writing that until after the tag event, after we've seen the regolith on the surface of the asteroid, after we've done the sample mass measurement, we have some sense of what we're getting back, then they can really get to the details. We have lots of great concepts and ideas and outlines of what we want to do based on what we would use using instruments that exist in laboratories today. But I know NASA is going to be investing in cutting-edge laboratories for sample analysis as we move forward over the next 7 years. So that'll also shape our analysis plan. We will get that material from the Utah Test and Training Range into the Astromaterials Curation Facility at Johnson Space Center as quickly as possible. And then we have a great team there. They know exactly what they're doing in handling astromaterials. The same facility that's responsible for the Apollo samples, the Stardust Comet dust samples, Antarctic meteorites, and many other astromaterials collections. We have an obligation to the agency and to the community to get a sample catalog out within 6 months of Earth return. So a lot of our initial focus will be on just understanding the nature of the collection. What do we have? What is the grain size distribution? We'll do some quick look science to get a sense of where we are. And then we have 2 years of funding after Earth return to do the full sample analysis science. So we're going to carefully and methodically go through, and something like the chiral nature of specific amino acid compounds, that's a very careful measurement, very dedicated measurement, and we'll work through the technique, perfect it before we apply it to the OSIRIS-REx samples.
Okay, we'll take a couple of social media questions now, and then we'll come back and do some more here in the room.
Hi, yes, we have a lot of great engagement on social media for this mission. So Kevin on Twitter is asking, was the 2-hour launch window purely a function of orbital mechanics?
Yes. Tell Kevin it's done with math.
Right. I would say it's a combination of the orbital mechanics and the capability of the Atlas V launch vehicle, right? So you get an energy window, and the beginning of it and the end of it are set by what your launch vehicle is capable of delivering to you. So We started out with a 30-minute window, and as the Atlas V team finished their analyses and refined the capabilities of the 411, the spacecraft mass got determined. They were able to open that window up to give us the full 2 hours a day, and also the 34 days starting from now.
All right, this next question also comes from Twitter. Is there any chance that the sample could be altered at all when it comes back to Earth?
We are very cognizant of contamination control on this program, and so we have done a great job cataloging all of the materials that that sample return capsule is made out of, all of the materials that have been used to handle it, to clean it, adhesives and solvents, all of that we've sampled and we've documented. So we have done a great job. I mean, Lockheed Martin really took on the challenge of delivering us a clean sampling mechanism and a clean sample return capsule. But we recognize that there's always going to be some level of contamination, absolutely, because you reach a certain cleanliness level dictated by your requirements and your capability to verify those requirements. And so in addition to flying the sampling mechanism and the return capsule, we've got a phenomenal collection of witness plates on the TAGSAM head itself, inside the sample return capsule, and they're time phased. They'll open and they'll close at different stages of the mission to document any contamination that was required before the sampling event, during the sampling event, and then during the return cruise phase home. And so we'll be able to remove that signal from any chemical analysis that we perform.
Awesome. All right, this last question also comes from Twitter. And this person's asking, I know the mission is a 7-year mission. They want to know, how long will OSIRIS-REx actually be at Bennu?
So OSIRIS-REx will arrive at the asteroid in August of 2018. That's when we begin our approach phase. Nominal timeline has us acquiring the sample in July of 2020. So we'll spend almost 2 years mapping, selecting the site, verifying the spacecraft capability and the procedures for collecting the sample. We actually can't leave Bennu until March of 2021. Similar to the previous question, based on the capabilities of the spacecraft propulsion system and the orbital phasing between Bennu and target Earth, we have to wait till our departure window opens up. And so we won't be able to leave until March of 2021. All return trajectories get us back on September 24th, 2023.
All right, let's come back and take some other questions here in the room, right here.
I'm from NHK, Japan Broadcasting Corporation. First, congratulations on a beautiful, gorgeous launch today. It was worth watching flew all the way from Japan for our crew. And my question is on the principal investigator, Mr. Dante Loretta. You just mentioned a little bit about the Rosetta missions a little bit 2 questions ago. And I wonder, in terms of what they have discovered and then showed us, what do you see that Rosetta mission, and how do you want for the OSIRIS-REx mission to make their journey?
The Rosetta team are phenomenal colleagues of ours. They're our friends, they're our comrades. We're all in this business together. We're all exploring the universe, and we're happy to share our scientific information. The Rosetta team has been particularly generous in also sharing a lot of their operational lessons learned. In fact, our team has gone out to visit them in their operations center on multiple occasions, and we've brought a lot of important lessons back with us about how you orbit around a small body like this, how you operate, how you use your optical navigation systems to determine your spacecraft state, and then how you go through the process of sample site selection. I thought you would also ask about the Hayabusa mission, and I do want to give a lot of credit to the Japanese Space Agency. We learned a lot about asteroid proximity operations from the first Hayabusa mission, and we have a nice, strong collaboration that the agency has established with JAXA for working with the Hayabusa 2 team. Maybe Jim wants to elaborate on that.
Yeah, I'll be happy to. JAXA is going with Hayabusa 2 to another asteroid, much like Bennu. It has many of the similar characteristics, and it's going to be able to get some samples for which what we'd like to do is be able to exchange those samples and examine them as part of a larger group of asteroids, not just the single one, but a family of asteroids. So internationally, we have strong ties with our Japanese colleagues. So we also have many European colleagues that are in this business of sample analysis. They request samples out of our archive and go through a process of review and then distribution of those samples and write scientific papers. And I think over time, as we see each of these international groups improve their ability to do sample analysis, we'll be able to share a lot more of the science with them as we all work together internationally. It's really an international effort. You know, planetary science is all about our solar system. It's humanity's solar system. You know, let's take it. And that's what we're doing with going to Bennu and bringing samples back.
Yes, right here in the front.
Hi, congratulations, first of all. I had a question. As OSIRIS-REx approaches Bennu, it said the team's going to rely on two different forms of navigation, star-based and landmark-based. I was wondering if you can tell me any problems that might arise with either, and then how long the team will spend on each method.
Right, so when we first, even starting now, the navigation team will be using starfield-based optical navigation, and it's inherent in the spacecraft system, but also as we start to refine our orbit trajectory, especially during the approach phase to the asteroid, because the asteroid will start out just as a single point of light, and we'll image it against the background starfield images to refine our approach maneuvers and the trajectory. We've designed the early phase of the mission to make that transition, and that transition will take place during what we call orbit phase A. And so the spacecraft team, the navigation team, will continue to use starfield-based optical navigation while we build up a series of landmarks on the surface of the asteroid using our camera systems and our shape modeling software to identify and register to a coordinate system where those landmarks are on the surface of the asteroid. So for a while, they'll be running both systems in parallel, starfield-based optical navigation, and we're pioneering a lot of techniques there because we've got a very wide-angle camera we call our NavCam that's capable of getting the asteroid in the center of field of view and the stars in the background. So you can kind of start to do body-centered navigation. And then ultimately, they'll have to make that transition over to optical navigation landmark tracking. I don't anticipate any problems with those because we've simulated the mission, literally generated every image synthetically that we expect to get from the camera systems and run it through the navigation filters, done all the thread testing, and the team is ready to do it. So unless Bennu is a perfect cue ball with no features on it, landmark tracking optical navigation is going to get us where we need to go.
All right, we'll take one more question and then we'll wrap up.
Okay, thanks. Mike Wall from FlightNextSpace.com. I just wanted to say congrats to everybody on a great launch and best of luck in the future. This may be a silly question, and I am sorry if it is, but is it possible, actually using some of our ground-based assets to get a radar image of OSIRIS-REx around Bennu? Is that a possibility that where we could actually see the asteroid and the spacecraft together?
Well, we have some really great facilities, not only that NASA has, but we even use Arecibo, which is managed by the National Science Foundation, and it's a tremendous asset for us. Unfortunately, during the times that OSIRIS-REx is at Bennu, it's so far away we wouldn't be able to use radar. We have to let them come really close to us before we're able to do that. Within 20 million miles or so is just right at the limit of what we can do. So won't happen this time.
All right, that is going to conclude our news conference and the coverage of the launch of the OSIRIS-REx spacecraft. Thank you very much.